With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, this is our question. Let me explain this question to you. An impure sample of sodium oxalate Na2C2O4 weighing 0.20 gram is dissolved in aqueous solution of H2SO4 and solution is titrated at 70 degrees Celsius requiring 45 ml of 0.02 molar KMnO4 solution. The end point is overrun and the back titration is carried out with 10 ml of 0.1 molar oxalic acid solution. Find the purity of Na2C2O4 in the given sample. Right. So before understanding the purity concept, we have to look at the chemical reaction between the sodium oxalate, that is Na2C2O4, with the sulfuric acid, that is H2SO4. This will lead to the formation of sodium sulfate and along with that oxalic acid H2C2O4. Right. Now the next reaction which will be taking place between the oxalic acid H2C2O4 plus potassium permanganate KMnO4. Here we will be getting the conversion of plus 2 manganese along with the formation of potassium oxide and 2 moles of CO2 plus water. Right. So now if we calculate the N factor here for the oxalic acid, if we have a look at this part, carbon plus 3 is changing into the plus 4 oxidation state, right? So here there is a change of 1 electron that is happening, but we have 2 carbon units involved here. So it will be basically equal to 2, right? So N factor for this will be equal to 2, and if we have a look at the potassium permanganate, manganese is changing from oxidation state plus 7 here to plus 2, right? So clearly there is a change of the 5 electrons, so we can say N factor for potassium permanganate will be equal to 5, right? Now what we have to simply use the concept that molecular equivalent of or milli equivalent we can say of Na2C2O4 will be equal to that of the KMnO4, right? Here this KMnO4 is used for the Na2C2O4, right? So now what will happen if we substitute the values here? It is also given in the question that the endpoint is overrun. So on the back titration, 10 ml of 0.1 oxalic acid solution has been used here, right? So we need to subtract this amount also for the back titration. So here it will become 45 into 0.02. Why 45 into 0.02? Because it is given to us in the question only that requiring 45 ml of 0.02 molar KMnO4 solution. So for that we have taken it, and the N factor of KMnO4 which came out to be 5 minus subtracting that volume 10 into 0.1 into 2. How this came? Because from the same data 10 ml of 0.1 molar oxalic acid multiplied with the N factor of oxalic acid, that is 2 here, right? On solving this we would be getting 2.5 milli equivalents of Na2C2O4, right? So now we would be simply calculating the weight of Na2C2O4. For this, we will use the simple expression milli equivalence of Na2C2O4 in the numerator. That will be equal to 2.5 multiplied by 10 raised to minus 7 because it is the milli equivalent. So we are multiplying with this 10 raised to minus 3 divided by N factor of Na2C2O4 that we have just seen will also be 2, right? Multiplied by its molecular mass which comes out to be 134. From here we would be getting 0.1675 gram. Right. Now after obtaining the weight of the compound, we can now find the simple percentage purity that we are actually supposed to calculate. So just putting the formula for the percentage purity, we will take the weight of Na2C2O4 that we just calculated as 0.1675 divided by the total weight that will be 0.2 here, and for the percentage we have to multiply it by 100, right? From here it comes out to be equal to 83.75%. This is the final answer. So if we go and check the correct option, option number B is the correct answer. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.